While I'm working on some more involved and lengthy videos, I thought I would address some of the questions that I've gotten in some previous videos. One of those was, what engineering books do I have and do I like? Because I've had showed my bookcases in a couple of videos and people have asked. So I thought I would start that off by giving a quick summary and review of my best non-technical engineering books. Everybody knows Machinery's Handbook and a couple of others, and I will do a video on those, but these ones I think have the potential to make a bigger impact on your engineering career and just your engineering mindset in general. So I'm going to go through these. I've never done a book review on video before, so we'll see how this goes. Hopefully it's enjoyable. I'll put links in the description to as many of these as I can find. Some of them I've gotten at like used bookstores and things, and some of them I've gotten on Amazon, so you'll be able to find them. This first one is 101 Things I Learned in Engineering School. And if I'm honest, it's probably would be more accurately titled 101 Things I Learned After Engineering School. These are a lot more kind of life lesson, industry learned lesson kind of things and less things you learn in school. There are things you should learn in school, but I don't think you usually do. So I have some tagged items here and we'll just go through them. So the first one I have dog-eared here is: the heart of engineering isn't calculation, it's problem solving. And I 100% stand behind that. I feel like engineering as a whole gets a really crazy reputation. I mean, it's mostly based on school because you do calculations in school and not very much problem solving. But it's got this little diagram here that shows a cycle of engineering that starts off as identify problem, expand problem space, identify opportunities and constraints, identify benchmarks. Then you get on to like brainstorming and testing, evaluating, and then it's a continual loop. And on this page, it says, school may teach the numbers first, but calculation is neither the front end of engineering nor its end goal. Calculation is one means among many to an end, to a solution that provides useful, objectively measurable improvement. That completely sums it up for me. I think that's a great phrase. Here's another one. It's accuracy and precision are two different things. And I see this one thrown around in meetings all the time, and a lot of times people don't get it. So here is the graphic, and so it says 3.14 is accurate and imprecise because it's accurate, but it's not very precise, right? It doesn't have many digits. Down here has a whole bunch of digits. It's inaccurate and precise because it's not right, but it's very precise because it has lots of decimal points. This one is accurate and precise because it has a lot of digits and it's correct. And in the text here on the other page, it says, accuracy is the absence of error. Precision is the level of detail. Effective problem solving requires always being accurate, but being only as precise as is helpful at a given stage of problem solving. Early in the problem solving process, accurate but imprecise methods, rather than very exact methods, will allow consideration of all reasonable approaches and minimize the tracking of needlessly detailed data. I think that's pretty good. So this page talks about how there's always a trade-off. There's a little comic here that says, I got that pump up to 6,000 GPM, but it's 40 pounds over target. We're at our limit. See if someone else in the team can give you 40 pounds. Things are always bouncing around like that. You either got efficiency or cost or scheduling or size constraints. There's always trade-offs. There's never a super ideal component or design. So you're always working in a world full of trade-offs. And over here it says lightness versus strength, response time versus noise, quality versus cost, responsive handling versus soft ride, speed of measurement versus accuracy of measurement, design time versus design quality. It's impossible to maximize the response to every design consideration. Good design is not maximization of every response, nor even compromise among them. It's optimizing among alternatives. This is one that I bring up all the time. Early decisions have the greatest impact. And if you think of your design process for a project as a voyage or something, right? The turns you make on that map or on the road early on are going to affect the outcome the most. If you start off heading east when you should be going west, that's going to be a big deal. Versus when you're 99% there and you take a wrong turn, make another couple of right turns and you're there. Decisions made just days or weeks into a project, assumptions of end user needs, commitments to a schedule, the size and shape of building footprint, and so on, have the most significant impact on design, feasibility, and cost. As decisions are made later and later in the design process, their influence decreases. Minor cost savings can be realized through value engineering in the later stages of design, but the biggest factors are embedded at the outset in a project's DNA. That's super true. If you start a project and everybody agrees, yes, the frame has to be carbon fiber, you're locked into a certain amount of cost there. Whereas if you had kept that open and maybe started with fiberglass and then go through the process until there's a reason to go to carbon fiber, you might save a huge amount of time and expense. Something else as engineers and designers you always have to keep in mind is to not presume the solution. To keep in mind that your first idea isn't necessarily a good solution. The idea of your manager or somebody else, their first ideas are probably not the best ones. To really evaluate all the problems and ask all the stupid questions up front, really to find out the lay of the land of what your options really are. So in the text here it says, at the point a designer is invited into the design process, many assumptions have been made about the nature of a problem, its causes, and the desirable solutions. The wise designer begins by moving backwards, investigating what causes the problem, what caused the causes, and what caused those causes. This reveals possibilities that might be very different from what the end user anticipated, but that meet the true needs most effectively. Every time I work with a new client, I tell them right up front, I'm going to ask a bunch of dumb questions the first day or week. I'm really just trying to explore and kind of push the limits a little bit just to find out where those limits are. A lot of times people that have worked on a project or in a certain industry for a certain amount of time, they see things through a certain lens, and so they only see certain solutions. And being able to come into it with a fresh set of eyes and really ask the super basic questions, you might be able to narrow down a project from a huge, multi-million-dollar thing down to nothing. We don't actually need that part. So that's 101 things I learned in engineering school. It's not a book that's going to change your life, but it's a really cool coffee table, thumb through every once in a while and pick up an idea or two. I found it pretty enjoyable. Not all of them they're definitely not all mechanical. There's a fair number of civil-minded. There's bridge type examples in here, but I obviously gravitate towards the mechanical ones. So I recommend it. I thought it was a pretty good book. This one I had never heard of. I think I found it in a used bookstore. It's called The Universal Traveler, A Soft Systems Guide to Creativity, Problem Solving, and the Process of Reaching Goals. Super broad topic, right? And the inside is just super funny to me. It's like the Monty Python's version of engineering learning. It's full of really funny roadmaps and things, big, old-timey sketches. While it does look kind of funny, it really does dig down into some of the core thought processes and how you approach problems and solve them and learn from them. I've got a couple of things dog-eared here that I'll talk about. So this chapter here is some keys to creative behavior. They go into a paragraph on each of these, but I'll give just the headlines here. So one is freedom from pride, definitely. Belief in self and the ability to succeed. Constructive discontent, wholeness, the ability to control habit. It talks about blocks to creativity, how logic makes sense. And then the rest of the book is the design process, and they talk about it as it's a problem-solving journey. So the steps that they go over here are to accept, analyze, define, ideate, select, implement, and evaluate. And then it goes through and it gives you the same roadmap I showed you a little earlier. And it talks about going through the process, and then it talks about different ways to look at the process, whether it's a loop or a step-by-step, is it serial, parallel? It seems kind of silly, but sometimes you read through a paragraph or two, and then at the end, it gives you a language guide for that certain portion of the design process. And you read through them, and some of them don't really mean anything to you, but some of them will kind of hit home more, and you'll really, that's what they were talking about when they were talking about some other issue. So I thought that was pretty cool. So it goes through each of the main steps in the design process. For this is acceptance, so it gives you an introduction to acceptance, and then it gives you a language guide for acceptance, and then it gives you methods for acceptance. So it's talking about what it is and how you would actually apply that in the real world. And then at the end, it gives you references for other books to look up on the topic. And each one of these little steps are super valuable. I just think they're super interesting. Nothing in here is meant to be like a very constraining, specific step-by-step process. It's all a little bit vague, but very informative and kind of guiding. I find it a lot more useful than just bullet points. I mean, in some engineering books, this whole book would have been 5 bullet points, and then you just go figure it out. Whereas in this book, it gives you 5 different ways to think about something. So I think it's super interesting. I've gone through it a couple times over the years and kind of pick up different ideas from it each time. So highly recommend it. It's a little off the beaten path, little interesting, but it's worth a read. All right, this next one is What Do You Care What Other People Think? And it's a collection of stories about and kind of told by Richard Feynman. If you don't know who Richard Feynman is, he's a theoretical physicist. He unfortunately had a lot to do with the development of the atomic bomb, but he also had a lot of other super interesting things that he did. He taught at Caltech, and he's generally just an interesting, kind of funny, mischievous guy. One of the things that he's really well known for is being part of the panel that investigated the Challenger disaster in the 80s, the shuttle that blew up. And so that's what probably 2/3 of this book is about. It's kind of his narration of that whole process of going through that panel and all the investigation into what caused the explosion. The first part of the book is kind of some stories about his childhood and earlier life, some funny stories and things to kind of set the stage, and then the majority of it is for the Challenger investigation. There's a lot of like fairly detailed pictures of cross sections of parts of the shuttle, so you can kind of understand the technical part of what he's talking about. But a lot of what he does is talk to people, ask the right questions. Doesn't really kind of follow the standard political procedure that he was supposed to. So it's super funny. Like I said, he's a super funny, like kind of sarcastic guy. You should definitely look him up if you haven't heard of him. There's tons of YouTube videos about him or of him. Some of them are super technical, like he'll be explaining some theoretical physics or string theory concept that I have no idea. But there's a whole bunch of him, and I'll link him in the description, where he's in a recliner, like explaining simple physics concepts. He explains like how a rubber band works and why it stretches back and forth. There's a whole bunch that are just super interesting. He's super funny to listen to, so definitely check it out. There's another book by the same author called Surely You're Joking, Mr. Feynman. That's a good one too. It's not a super long read, but I think it was super fun. So this one's called The Unwritten Laws of Engineering. And I wouldn't usually go for a book like this, but Laws of Engineering sounds very formal. I think this one is especially good for people who haven't worked in an office before, just to get an idea for office dynamics. There's things in here that are like politeness kind of issues, like how to deal with your boss, how to deal with performance reviews, who you should really be paying attention to when like 5 people are giving you tasks. So like this section here is regarding relations with colleagues and outsiders. It's all written like very formal, but you can get the good points out of it without being too dry. This one is this is actually super valuable. Don't get too excited in engineering emergencies. Keep your feet on the ground. Very good advice. It's too easy to get wrapped up in the oh my gosh emergency-ness of it. Be content to freeze a new design when the development has progressed far enough. You can work on a project forever, but there is a line where it's good enough. So keep an eye out for that. That's a good tip for sure. Always accept full responsibility for your group and the individuals in it. So if you're leading a group, it's on you. If somebody messes up that's in your group, then it was your job to have them on the right path. And if it didn't work out, then it's on you. It's fine. I mean, that happens. But if you just push the blame onto the person below you, it's not going to fare well in the long term. If you're leading projects in the future, people will remember that kind of stuff. So always take responsibility for anything that's under your rule. And here's a whole laws of character and personality. So like I said, it's written very formally and very kind of rigid. But I think for people that are maybe just graduating, I think it'd be a super valuable thing just to read through it. Obviously, some of it, some of it's kind of like old school engineering, in the 50s kind of very hierarchical kind of stuff. But overall, I think it has really good advice as far as the design process and responsibilities and courtesies and things like that. So it's worth a look. This one is Every Tool is a Hammer by Adam Savage. I've been watching Adam Savage since he started Mythbusters. He's always spoken to me. I really like his ability to prototype things really quickly and move fast. But actually, over the last couple of years, when he started the Tested YouTube channel, he's talked a lot about his design process and how he works. And a lot of that's actually pretty inspiring and applicable to engineers, I think, as well. So, like I said, I've got a lot of dog ears on this one, but I've got just a couple here that I'm going to read out for you. This one, he says, that's the cruel joke of making, or any creative discipline for that matter. No matter how much you progress in your career, the duality of thrill and terror that exists with all new things will never leave you. In fact, the better you get and the more experience you acquire, the better you are at understanding objectively where your work and your wisdom fall short. Self-doubt never leaves the attentive craftsperson, so you best make friends with it. And if you don't know how, here's some advice. Have the patience and humility to ask someone who's been there before. Very, very true. I always do my best, at least, to be humble and just learn from other people's experiences. If I'm getting into a new industry with a new client or something, they know more than me about it. I know more about other stuff, and that's why they're bringing me in. But I'm there to soak up as much information as I can. So know as much as you can, but understand that you don't know everything. This one actually kind of bugs me. I see this all the time in media, and I think I've actually heard him say it on his YouTube channel. So he says, imagine hanging a door and sliding the steel pins through the holes of each door hinge. If the pin fits loosely in the holes and rattle around a bit after insertion, that's a loose tolerance. If the pins fit snugly and need a bit of pressure to thread through the hinges, that's close tolerance. So close. Those things are tight and close fits. Tolerance is, a variance allowed on a dimension. So either the hole or the pins could have a tight or a loose tolerance, and those both contribute to the fit of those things going together. And it's definitely not just Adam Savage. Like, people misspeak this all the time. So tolerance is just a variance allowed on a dimension of a part. The fit, like how snugly something fits together or how sloppy it is, that's the fit. It's not the tolerance. The tolerance is the actual dimension. So when you press fit a pin into a hole, it's because of the tolerance on each of those parts. But it's not that you can't just call that fit a tight tolerance. That doesn't make any sense. I know I'm nitpicking. I just had to bring it up. Still love you, Adam, but that's something that's always irked me a little bit when I hear people say it. Last one here. I've learned that a craftsperson isn't someone who doesn't make any mistakes. Master craftspeople are confronted with all the same problems and pitfalls as any other maker. They just have the experience to see these hazards coming from farther away than the newbie. And in seeing farther, they have more time to get out of the way. Definitely. I see this all the time when I work with really young engineers. As soon as a project or even a simple task starts, I'm asking questions about how it's going to fit into the overall assembly and what issues there could be down the road, lead times and, shipping delays and things like that. I'm just looking at things down the road, and I'm trying to get small tasks out of my way that somebody else could be working on at the same time. It's just experience you gain over time, but always try to think about that and learn and notice things that you could have done earlier so that you can realize that next time and try to get ahead of it. Last one, Inventors at Work. I don't usually read books like this, but it's basically a big collection of interviews with founders and inventors and CEOs and all different kinds of people. I'll put a list of the people that they interview in the description. But he asks basically the same questions of each person. He asks about their background, when they grew up, were they always inventing things, and then they kind of asked a little bit more specific questions about what that person did. There's electrical stuff in here, there's software, there's chemistry, there's engineers, there's just like straight founders, like non-technical founders. It was super interesting. So some of the ones that I noted was Steve Gass. He's the inventor of the saw stop. So you get to learn about the history of like when he came up with the idea, went through the prototypes, and then tried to sell it to other saw makers, but nobody wanted to buy it because the existing saw manufacturers said safety doesn't sell. So he had to totally change his plan. He just wanted to sell the idea basically and move on. But he ended up having to develop the whole product and do the whole manufacturing and selling and everything. So it's interesting seeing how the path of a lot of these products changed over the course of their development. This one is an interview with Tim Leatherman, the founder of the Leatherman Tool Group. Talks about the whole story of how he came up with the idea and the need for the Leatherman and how he built the company from just him to what it is now. A lot of the people in here started off at companies when they were really small. And as time went on, they kind of got to adapt this role of a technical kind of guidance person for all the projects and R&D stuff that went on. I've seen a couple of people in roles like that, and their titles are all over the place because it's not a really well-defined role in a company. One of the best engineers that I've ever worked with had a role like this, and it was super valuable to everybody that worked in the department to be able to get input from him and glean little bits of experience and lessons that he'd learned over the years. I think reading these, you can kind of pick up those little bits, especially if any of the people are in an industry that you're super interested in. That's obviously more applicable, but they all have technical and personnel and sales and all different kinds of challenges that they have to deal with that you end up having to deal with in your career. So super valuable interviews and lessons learned from a bunch of really influential people. So inventors at work. So I hope that was helpful. I hope you have a book now that you want to check out and read. Let me know if this was useful to you, if you want to hear more stuff like this. I'll definitely, like I said, I'll do one for more technically minded type books, but I think most of those are a little easier to find. I think these ones on kind of the soft skills are a little bit harder to find the gems. So I thought I'd start here. So hope you got something out of that, and I'll see you next time. Thanks.